Next topic is forces between multiple charges. Forces between multiple charges. So that is superposition principle of charges. Superposition principle of charges. Okay, forces between multiple charges means, see here, this is the x direction, this is y, and here we are taking the coordinates, 3 coordinates. Okay, so now let us consider, here is one charge is there, that is a q0 charge. Okay, so test charge. So here the distance from this charge taken as, just take the position vector is or not. Okay, now here another charge is there, the distance from the origin to this charge is, let us take r1. So this is a q1 charge, take here is a q2 charge is there, this is a q2 charge, so the distance is r2. So that means the position vector from the origin to the charge. And here let us take q3 charge, and this is the r3 position vector. Okay, so now here this is the charge. Now I want to apply the force, that is here so many charges are there, so this q1 applies the force on this charge, and q2 also applies the force on this charge, and q3 also applies the force on this charge. Okay, so that means here q0 is the test charge. Test charge means it is being under the tested. So that means here so many charges, that means here n number of charges are there, those the effect by those charges will be, we have to calculate the effect of all those charges on this charge. Okay, so that's why this considered to be a test charge. Okay, so now I want to get the effect of all those charges on this charge. Okay, so now here we can written as the total force on test charge. This is the total force, the total force on test charge, the total force on test charge, that is a q0 due to n number of charges, which are at rest. Okay, not moving, because we are studying about the electrostatics. Which are at rest is the vector sum of all forces on that charge due to another charges, at some time t. చూడండమ్మా, so here one test charge is there, so this q1 applies the force on q0, q2 applies the force on q0, and q3 applies the force on q0, and if n number of charges are there, n number of charges individually applies the force on q0. Okay, so here I want to get the force on this test charge. Okay, I want to get the effect which is given by all those charges. Okay, so that means I want to get the total force which is applied on this q0 charge. Okay, so to get the total force, here we have to sum up all over the forces which is given by the individual charges. Okay, so this q1 charge applies the force, that is the f1 force. Let us consider this is the q1 which applies the force on this q0 in this direction. So this is the force on test charge due to the first one. Okay, now here this is a q2 charge, it applies force on the q0 in this direction. So this is the force on the test charge due to the second one. Okay, now this is the charge which applies the force on q0, so here this will be in this direction. So this is the force on test charge due to the third charge. Okay, now here we are getting the 3 forces which are acted on this test charge. Okay, by taking the sum over all those charges, by taking the sum. Okay, now we are getting the total force which is acted on the test charge. Okay, now here the force due to individual charges will be unaffected by the remaining charges. Okay, so that means this if f1 force acted on the test charge due to the first force, but this force is not affected by the another charges, and this force also not affected by the remaining charges, and this force also not affected by the remaining charges. Okay, so here we have to take the forces are which is due to the individual charges. Okay, now here we are getting what f01 and f02 and f03 are the forces acting on test charge, okay, so that is due to what, due to q1, q2, q3. Okay, now here we have to get total force. Okay, so that is total force acted on q naught test charge. Okay, so that is to get the total force, here we have to take the vector sum. Okay, so that is the total force f is equals to force due to first charge, force due to second charge, force due to third charge, like this, force due to n charges. Okay, so now according to the Coulomb's law, already we know that the magnitude of the force, so the magnitude of the force is what, 1 by 4 pi epsilon naught q1 q2 by r square. So this is the magnitude of the force which is given by the Coulomb's. Okay, now here for the total force, this is the force which is acted on the test charge due to the first one, so we can written as 1 by 4 pi epsilon naught. Here why here we are writing the epsilon naught, because we are taking the media in between those, one is vacuum or the space. Okay, so here we are considering the air or the vacuum, okay, in between those charges. Okay, so 1 by 4 pi epsilon naught, q1 is what, 0, and q2 is what, 1. So this is the test charge and this is the force applied charge, and here we are taking the position vector. Position vector is from first charge to test charge, that is whole square. Okay, now here we have to take the unit vector, so that is r10 cap. Okay, this gives the direction of that force. Okay, so in the before class also we have taken unit vector which gives a direction. Okay, so here r1 cap means what, r10 vector and r10 magnitude. So this gives the magnitude and this gives the direction. Okay, so here we are writing the unit vector to get the direction of that force. Okay, and place here 1 by 4 pi epsilon naught, and now f02 means what, on the test charge q naught, and that is by the q2, and the position vector is from 2 to 0. Okay, so that whole square and r20 cap. Place again 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q naught and q3, that is by r30 whole square and r30 cap. Place, and the so on. If you are taking the n charges, that is 1 by 4 pi epsilon naught, so what, q naught and qn by rn0 whole square and rn0 cap. Okay, now here 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught common. Okay, so everywhere we are having 1 by 4 pi epsilon naught common, and q naught also common here. Okay, so we are having the q naught, so just common out all those one, so 1 by 4 pi epsilon naught and q naught also. But see here, okay, 1 by 4 pi epsilon. Okay, so see here we are having the 1 and 2 and 3 and n. Okay, and here also we are having 1, 2, 3, n. Okay, so that means here n number of charges are there. So now here we are taking the that is sign, so that is a summation. Okay, so in the mathematics we are having the summation to sum over all those values. So this summation is from what, I is equals to 0 to n. Okay, so here I is equals to 1 to n, because we are taking the 1 no, so I is equals to 1 to n, that is q naught is constant, the test charge is constant, but here we have to take the I here, because if I is equals to 1, q1, I is equals to 2, Q2. I is equals to 3, Q3. I is equals to N, Qn. That is by, and R1, R1 0, R2 0, R3 0. So that is Rn 0. Rn 0. So that means here we are taking the I. So I 0, Ri 0 square. And here Ri 0 cap. Okay. So if I is equals to 1, R1 0, I is equals to 2, R2 0, I is equals to 3, R3 0. Here also I is equals to 1, R1 0, R2 0, like that. Okay. So now the total force F is equals to 1 by 4 pi epsilon naught summation over I is equals to 1 to N Q naught Qi by Ri 0 square and Ri not. Okay. So here we have to get the direction. So for the direction we can also written as F is equals to 1 by 4 pi epsilon naught summation over I is equals to 1 to N and Q naught Qi. So this is the Ri 0, no? So it can be written as what? R0 minus Ri magnitude, and here this also written as, so this can be written as Ri R0 minus Ri. Okay, so this is a vector form. So here we have a vector form and here we are having the magnitude. So that is R0 minus Ri magnitude. Okay, so here we are getting the square, no? So by combining those two we are getting what? 1 by 4 pi epsilon naught summation over I is equals to 1 to N Q naught Qi by R0 minus R1 whole cube into R0 minus R1. Okay, so this is the force between the multiple charges, that is a superposition principle. Okay, so here we are finding the total force which is acted on the Q0 due to Q1 charge, Q2 charge, Q3 charge, atla n charges. Okay, now okay, so we are entering into the new topic, that is electric field. Electric field. Okay, so electric field means here we are considering the charge. This is a charge. So as it is a charge, it has some effect over the space. Okay, so that means the space around this charge, the space around this charge, that is the effect of this charge is known to be a electric field. Okay, so that means here electric field means the space around the charge, the space around the charge. Okay, so that means it can be expressed in terms of electric force of attraction or the repulsion which is experienced by the other charges. Okay, so that means here we are placed the another charge. So the effect of this charge can be experienced by the discharge. Okay, the effect of this charge is experienced by the discharge. That means the how much space it is occupied, okay, to apply this effect. So that is the electric field. Okay, so that means electric field means the effect of the charge. Okay, effect of charge. Okay, so here this effect can be experienced by the another charge. Okay, that may be attractive force or the repulsive force. If it is a negative charge, if it is a positive charge, then there is some attraction between those two ones. If it is a positive, then there exists a repulsion. Okay, so that may be depending on that one. Okay, so this is given by the Faraday. And here we are having the two types of charges. One is source charge, another one is the test charge. Okay, already we know about test charge, that is Q, and source charge means Q. Okay, so source charge means it is producing the field, electric field, it gives the electric field. So test charge means it will test effect of the charge Q. Okay, that is test effect of source charge. Okay, let us consider here is a charge. So this is the source charge. So this giving some electric field in all the directions. So this is the electric field which is given by this source charge. Okay, so this effect can be affected by the another charge. Okay, so let us consider here is a charge. So this giving this effect. Now I am placing here another charge. Okay, now so the field force will be applied on this charge. Okay, so that means how much effect will be experienced by the second charge is the test charge. Okay, how much field is produced, that is the source charge. It is producing the charge, it is producing the field, and that field is experienced by the another charge. That means that the charge is getting some force by the source charge. Okay, so that charge is test charge, okay, which is under the test. Now here we have to know about electric field intensity. Electric field intensity. Okay, so electric field intensity means the strength of the field at that point. Okay, the strength of the field at that point. Okay, so let us consider here is the source charge, so this is giving some field. Okay, so these field lines are here we are having so many field lines, as this is a source charge, and we are getting the electric field lines like this all over the space. Now I am placing the test charge here. This is the charge I am placed here. So now this charge experiencing the effect of these field lines. Okay, so that means here these field lines of the source charge applies force on the test charge. Okay, so that means here electric field intensity means how much strength applied on, how much effect applied on the Q. If I am placing the test charge here, so then the effect which is done by the source charge is less. Okay, if I am placing the charge here, then the force experienced by the test charge will be large. Okay, so that means the electric field intensity means the strength of the charge at that point. Okay, the strength of the field at that point. Okay, so here I am considering the point. So the strength of the field is given by the force which is acted on that charge. Okay, so the force which is acted on that charge, this is the electric field intensity. Okay, so now here what we can write, the force experienced by unit positive test charge, test charge placed at that point. Okay, here we are placing the test charge. Okay, so this test charge experiencing this field force. Okay, now it E is equals to what? Force by charge. Okay, now here the direction of the electric field is always along the force direction. Okay, direction of E field, okay, is along the force direction. Okay, so the direction of the force is always along the line joining the two charges. The direction of the force is, here we are having the two charges, no? If this is a Q1 and Q2, the force, okay, so the force in between those two charges, here the force applied here, the force applied in this direction. That means the force direction is always along the line joining between two charges, and electric field direction also like that only. Along the force direction we are having the field direction, along the force direction we are having the field direction, and the force direction is always along the line joining of two charges. Okay, so now here we are having the SI unit for this electric field intensity. So that is force is equals to Newton, charge is equals to Coulomb. So that is Newton per Coulomb. Okay, now here we have to get the electric field intensity due to point charge. Electric field intensity due to point charge. Okay, so here in we are considering the only point charges. Okay, we are using the only point charges. If you are having the greater charges, then we can't use the Coulomb's law. Okay, so here we have to consider the point charges only. Okay, so that means they are having very small diminished size. Okay, So here I am having one source charge, that is Q. This is a source charge, okay, and here I am placing the another charge, that is the test charge, okay. So now I want to get the electric field intensity due to this point charge, okay. So now here we are having the line joining between those two charges. There exists some distance between those two charges. Now this source charge is placed at the point O, and this test charge is placed at the point P, okay. Now as this is the positive charge and this is the positive charge, so it applies the force on this charge, but as those two are positive, those two are repulsive, so the force will be in this direction, okay. The force direction is in this direction, okay. Now here I want to get the electric field intensity at this point, okay. Electric field intensity at this point P, okay. So that must be is equals to electric field is equals to, already we know that the force which is experienced by, not done by, the force which is experienced by the charge Q, okay. So here we are taking the test charge as a Q, okay. Let us consider this is a Q naught as a test charge. So already we know that the magnitude of the force is what? Magnitude of the force is 1 by 4 pi epsilon naught. And the two charges is what? Test charge, a source charge, and the test charge. And the distance between those two what? R. So R square. Okay. And this is the magnitude. Okay. But here we are taking the vector. Vector means magnitude and direction. So as it is a magnitude, and for the direction, here we have to take the R cap. Okay. So and that is by Q naught. So Q naught and the Q naught will be cancelled out. Here we are getting electric field intensity as, that is equals to 1 by 4 pi epsilon naught to source charge by R square into R cap. Okay. So this one is the magnitude. Okay. Magnitude of F. So this represents the direction of the F. Okay. So this is the electric field due to point charge. Electric field due to point charge. That means on this test charge, here we are getting the electric field by this source charge. Okay. Now here we have to get the electric field intensity due to system of charges. Okay. So now we have to get the electric field intensity due to system of charges. Electric field intensity due to system of charges. Electric field intensity due to system of charges. Okay. Now see here. So here is the test charge Q naught. Okay. So we are considering the so many source charges. Okay. So that is Q1. This is one source charge, and Q2 and Q3 and Qn. Okay. So all these are the source charges. Okay. So this source charge applies force on this test charge. So in this direction. Okay. And this applies the force in this direction. So this is the force which is due to the test charge, that is source charge Q1 on the test charge. And this is force due to second source charge on the test charge. And here this force is due to third charge on the test charge. This force is due to nth charge on the test charge. Okay. So these are the forces which are acted on this test charge due to the number of source charges. Okay. So now here we have to get the electric field intensity on this test charge due to all these charges. Okay. Now here electric field intensity electric field intensity, let us consider this is a point P. So now electric field intensity at a point P. Okay. So due to presence of group of point charges or the group of point charges or source charges Okay, so that must be equals to what? That must be equals to vector sum of electric field intensity due to individual charges. Individual charges at same point. Okay, so here we have to get the electric field intensity on the test charge due to all the source charges. So here this applies the force and this applies the force and this applies the force. Okay, so already we know that electric field is equals to force by charge. Okay, so that means here to get the electric field intensity we have to sum up all the individual electric field intensities. Okay, so that means the electric field intensity due to q1, electric field intensity due to q2, electric field intensity due to q3. Okay, so that means the electric field intensity at a point p due to present of group of point charges is equals to the vector sum of electric field intensity due to individual charges. Okay, so that means electric field at the point P must be is equals to electric field due to the first source charge, electric field due to second, electric field due to third, then electric field due to n. Okay, so that must be is equals to electric field due to only one charge is what? 1 by 4 pi epsilon naught. That is q by r square. No, so this is q1 by, here we are taking the position vector that is from the q1 to on the test charge. Okay, and here we have to give direction. Okay, so this is a q1 which applies the force on the q0. So this is r10 and this is r20 and this is r30, this is r40. We have to give direction also. Okay, now second one, 1 by 4 pi epsilon naught q2 by r20 square r20 cap. Next 1 by 4 pi epsilon naught q3 and r30 square and r30 cap. Okay, and so on. Here we have to get 1 by 4 pi epsilon naught qn rn0 whole square, that is rn0 cap. Okay, so now again here we have to use the summation to add all those ones. Okay, so then summation over 1 by 4 pi epsilon naught summation over I is equals to 1 to n, then qi and ri0 whole square and ri0 cap. Okay, this is the effect on the test charge due to all the source charges. That is the electric field at this test charge is equals to the electric field due the sum of electric field due to all over the charges. Okay, so this is the summation. So here I means I is equals to 1 q1, ikkada r10, ikkada r10 cap. Okay, next I is equals to 2 q2, next r20, next r20 cap, like that. Okay, so this is the electric field due to system of charges. Now we have to get some properties of the electric field.